recording? All right, and we're live. So, goal here is to help define some of the vocab stuff you've seen, some of the acronyms you've seen, big concepts, that kind of stuff. So, I asked you this morning to start putting together a list. What'd you come up with? Let's build something. I saw CI/CD. What else?
What do they mean by runtime environment?
I love it. Runtime. What else?
Did we already put Git flow? Sorry, I'm late. I didn't read the response correctly.
Brad, you're dead to me. Git flow. You're not actually dead to me, Brad. It's okay. All right. What else?
Like continuously deployed.
That's this. That's the CD. What else? Stuff you've heard at meetups, stuff you've seen in job postings.
Yeah, maybe like some of the stuff like Babel and Webpack and those kind of things. I don't really know what those are.
Babel, Webpack. What else? Does anybody know what .NET is?
Not really.
That's probably a thing worth talking about.
I think the issue when I look at this is always figuring out what I don't know, kind of thing.
Yeah. Same.
Well, this is okay. So let's. I'm going to share my screen. Let's go back through some Microsoft Stack. So Microsoft Stack is .NET, same thing. So I'm going to share my screen. Let's take a look through some of the gigs postings. And oops. Okay. All right, so look through this. Anything that you see in here that you couldn't define.
Our anchor, this position will be our anchor. Oh, that's UX, never mind. Oh no, it's full stack developer.
Our anchor, where are you seeing that?
It's on just under the today separator.
Will be our anchor. So that's not like a technical term.
Oh,
that's
okay.
like you will anchor this team, as in to keep it from going adrift.
Okay, got it.
Can we talk about client side versus server side?
Yes, love it.
I'm just assuming that Fluffer is a framework. I just saw something for a full-time Fluffer developer, and that just sounded hilarious.
Flutter.
Flutter.
Oh, is it Flutter? Oh, damn it, that was a whole Fluffer.
Fluffer's a different thing. Cool. What else? Some good ones in here.
Yeah, I don't know, like Elixir. I don't know what that is.
Wix? Where'd you see Wix?
I think it's an Elixir.
Elixir. Okay, very nice.
Hey, Kyle.
What else?
I have one.
Yep.
It's from a real interview I had. He was asking me about languages that compile versus imperative, I think.
Okay. Compile to languages And this isn't directly related, but I'm going to put imperative and declarative on here just in case. See some other things on this page that I don't imagine very many of you know what they mean.
Yeah.
ECS.
ECS, love it.
Yeah, seems to be related to AWS.
It is.
GraphQL. I don't really know
Yes.
what it is.
GraphQL. What else?
Kubernetes.
Kubernetes. Sometimes you'll see that also written as Kates. It's because there's 8 letters between the K and the S. You also see accessibility as A11Y because there's 11 letters between the A and the Y in accessibility. I18N, internationalization. It's a common way of doing acronyms. Kates. Anything else on here?
I kind of just like to know how to differentiate between the title of webmaster and web developer.
Sure.
Not really sure what that means.
Love it. Webmaster. It's a master of the web. And just titles kind of in general. All right, this is a good list. So let's start working it down. So CI, CD, some of these are related. So I'm going to say that CI, CD, ECS, and Kubernetes. These are all kind of related. So let's start with CI. So a lot of these, like, it might be hard to imagine them like not existing. Like, you already do some kind of CI stuff already, but it was not always the case that this stuff existed. So once upon a time, we've got 3 developers and they're all working on the same code base on their own computers. So the problem is, how do you keep them synchronized? Keep in mind, Git is kind of new. I want to say it was like mid 2000s or so, and it wasn't even like commonly used before like 5 years ago. I remember a team that I was on maybe 6 or 7 years ago, like switching over to Git, and it was like a big deal. So how would you do this? You got to keep 3 developers on the same page. Give me some ideas.
Work off a common server or work off of common files.
Yep.
On a remote server or a shared server locally.
Yeah, totally. So what you could do is have some kind of server here, and everybody is like remoting into it, and then working on the files on the server. Okay. What else? How else could we handle that?
I was just thinking like GitHub, where everybody's like pushing their own branch into like a master file or something.
Mm-hmm. So that requires something like Git. Git is a minor miracle. Like, you may not know this. Git was a project of Linus Torvalds. Linus is the LIN in Linux, and his other project was Git, which is like kind of an interesting. Like the math behind Git is pretty fascinating, and how that works and how it resolves conflicts and that sort of stuff. All right, but we don't have that. Any other guesses what we could do?
Work in person a lot.
Yep.
Just side by side pair programming.
So that was part of it. One of the things my team did is you would like call out the names of files you were working on. It was like, hey, I'm in init.js right now. Stay out of it for a sec.
Oh God.
Oh yeah, it was like, this is the very recent past. So another way that we could do it is you could check out little pieces of code, which is the equivalent of saying, please stay out of this file for the next hour. So you check out just that one file, and now it's locked, and nobody else can work on it. And then you check, like, make whatever changes you're going to make to that file, and then check them back in. And so this would result in all kinds of problems, like you could have somebody check out a file and then go on vacation or get fired, and now like nobody can access that file anymore. Oops. Also, one of the things that's really easy to take for granted with Git is this server over here. This is the only copy of our code. Yikes. So that thing gets in a fire, gets thrown off a cliff, power surge, whatever. Bye-bye code, it's gone. So versus the Git model, where when you like clone a Git repo, you have not only that code, you have its entire history, you have everything that you need. If every other person who's cloned that and GitHub all go down, you can still recreate. You've lost nothing. Everybody has a copy of the entire repo. That's pretty cool. So we needed a way to handle, even with Git, this problem of, all right, I made a change to this code that affects other people. They need a way to like see my updates and make sure that the code that they're working on isn't going to break just because I made a change to some file. And so what you do is you'd have a build server. And as you're checking in code, actually the diagram would probably look a little bit more like this. So if we say, I've got these 3 devs, and everything that they're doing is on GitHub. So I push and pull there, I push and pull there, I push and pull there. All right, so GitHub has like the most up-to-date version of the code. Easiest way to do CI is you are just pulling, every time a change gets made, you pull it down, and so you always have the latest version of the code. And what that does is when developer number 1 over here changes some shared file and pushes it up and it fucks up a lot of things, then these 2 developers find out immediately. And they go, oh, you changed that init.js file and now like all my shit's broken. What gives, man? So that's the idea behind CI. We want to find that out immediately, not in 3 months when we've all been like doing little things that break and break and break and break, and we can try to integrate them all together at the end of the project. The whole thing is like bucksword. So CI helps us get away from that. But we also want to use this as part of like a feedback loop for that developer. That developer also wants to go like, yo, I don't want to like completely break the app just because I'm changing this one file. How would I know? And so you have a CI server over here that every time you're pushing something to GitHub, it also goes to your CI server. They try to build the app and they run your tests. And if the tests pass, it goes, cool, rock on. You can safely integrate this code. If it doesn't, none of the other developers even see it because it'll go, whoa, 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 whoa. Before you pull this down, you should know that developer 1, when they push this thing up to GitHub, it breaks the app. So the CI server is telling you that immediately. Here's what that looks like. So I've been using this tool called Circle CI lately. these are different pushes to master. So every time something gets pushed to master, it does all of these steps. And if it does it without throwing an error, so this is like my running my tests. Those are Cypress tests that I wrote for this app. If they all pass, if all the unit tests pass, if we can boot up the app without it catching on fire, then we get to the next part of this, which is CD. So CI server says, cool, that thing worked out just fine. So it says, all right, you deploy this thing to Firebase and Heroku. Cool. If these tests pass, why not just push it? So it goes, cool, the tests are green. I'm going to deploy the back end to Heroku. I'm going to deploy the front end to Firebase. So there's no separate deployment step. As soon as you have passing tests, those go live immediately. That's continuous deployment. And sure enough, let's see.
So would an example of this be like in Heroku if you link your GitHub to automatically deploy? Is that
Yep.
an example of CI?
No, that's an example of CD.
Of CD, okay.
Yep. So the CI part of it is the part that runs the tests and checks to see if anything's broken.
Oh, okay. So then does CD stand for continuous deployment?
Yes.
Okay, got it.
Or continuous delivery. There's a slight difference between those, but they kind of mean the same thing. So here, this one. So you can set these up as like a sequence of tasks where it'll go, cool, I'm going to test the entire code base, and if it works, I want you to deploy the front end and deploy the back end. So all you have to do as a developer is merge something to master, and all of the rest of that happens automatically. If your tests don't pass, the deployments don't happen. So
What is that?
Go ahead.
What is that workflow called? Is that the CD?
Yep.
Okay.
So this entire app that I'm in right now is called Circle CI. So this is handling the CI part of it. But these steps that I wrote over here do my Firebase deploy. And so that ends up being the CD part of it. I saw something over in chat. SAS. Yep. Put SAS on the list. So the larger philosophy behind CD goes back to the Agile Manifesto. So we got these 4 values, but we also have 12 principles. If we go to the principles, our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And so the important word on this is continuous, not periodic. So you're not giving them valuable software every week or every month or every day. You're giving it to them as soon as you have it, continuously. So if I have done like valuable software and I've merged it into master and it doesn't break the app, why would I not deploy it? This is CI/CD. Questions about that?
So this has really only been recent because, like you said, GitHub was not too long ago. So all of this added stuff onto GitHub was really just kind of like the multiple cherries and whipped cream on top kind of thing.
Kinda. So this stuff existed before Git and before GitHub, but boy howdy was it gnarly. It's like it's finally a thing that you don't need to have a separate department in your organization to handle for you anymore. But my favorite book on the topic, Continuous Delivery, is a real thick one. And let's see how old this is. This goes 2011. So it's 9 years old. But a lot of the thickness in this book is trying to set up this CI/CD kind of thing without all the automated tools that we have in 2020. It's a lot easier to do now.
I also have a broader question. I was also wondering whether I hear this a lot coming from people who like do freelance work and stuff like that.
Mhm.
They say, you need to get your workflow or like your developer flow kind of going.
Mhm.
And is this kind of like related where it's like you need to have these underlying philosophies and how you program and stuff set in stone before you go ahead and start attacking big projects? So that would include stuff like Git flow, CI/CD, all these other things.
Sort of. Like, I'd be careful with set in stone because you always need to be flexible to reality. But yeah, knowing what done means is a really important part of your developer workflow. Because as you've seen in the projects you've done already, as you'll continue to see for the projects you do probably for the rest of the program, it's real easy to burn a ton of time on stuff that doesn't actually matter that much. You just can't let it go. And so you need to have some kind of backstop against lighting all your time on fire. And a lot of that just comes from developer maturity and like doing this for a while and knowing when enough is enough. There aren't really any like great metrics on that. But what I will say is things like the CI and CD server, CI/CD approach, test-driven development, testing, linting, some of these like what I kind of broadly refer to as quality tools. A big theme for me personally this year is trying to make those easier to use, because I think that software has better engineering tools than almost any other engineering discipline. Like, we can tell whether or not something works way easier than like a mechanical engineer or a civil engineer. You go back to that joke, like, how do they know how much weight a bridge can hold? It's like, well, they just drive heavier and heavier trucks over it until the bridge collapses, and then they just rebuild it and do whatever the weight was before it. It's difficult to tell some of that sort of stuff. We have way better tools and software, but they're crazy hard to use and configure and set up. And even like with Circle CI and these like automated deployment pipelines, check this shit out. If I go back to that, I've been trying to get this setup working for a while, and I got it more or less working now. But I see fields of red. Show me more. Look at all this fail. So much fail. So much fail. Show me more. All this stuff is like after it kind of started working. So much red. This was me trying to learn how to use Circle CI. Look at all that red. This shit's hard to figure out. I'm not new at this. I've been doing this a very long time. And it took me like almost 100 tries to get it to work for the first time. This is like unnecessarily difficult. And so I've been trying to lower the lift on using some of these good engineering practices and help with people's developer flows. Cool. Other questions?
What's a pipeline?
Sure. A pipeline is a series of steps. So this is a pipeline. I do this, and then I do this, and also this. That's a pipeline.
Cool.
Yeah, so as far as tools are concerned, I wish I could find this article I read, but it was kind of showing I don't know, it was kind of a satire. They were just showing how like ridiculous it can get with like chasing down like the newest, most trendiest tool. And it was like a developer from last year talking about like his tool setup. And then it was some guy like, it's like, oh my God, like what? Like those are so like outdated? Like,
Oh, yeah.
how do you avoid that?
You don't. Like, I was telling some of the new folks yesterday that, like, development is a sharks keep swimming or they die kind of profession. You just have to stay on top of that stuff. Because, like, 5 years ago, it was not only acceptable, it's fairly common to, like, use jQuery for pretty much your entire front end. And, like, that's a liability at this point. It was, like, kind of silly, like, not a good thing to do 4 years ago, 3 years ago. Now, like, there's, like, scaling and security problems with doing something like that. And so, like, as much as people say, oh, tech moves so fast, and it does, you see this stuff coming. Like, all these, like, unemployed Flash developers who are like, oh, my skill set is worthless. If you were paying attention, that train crash happened, like, in slow motion over about 5 years. And so if you got caught by surprise with that one, you kind of don't have anybody to blame. And I found that a lot of these, like, big evolutionary shifts are kind of like that. It's not overnight, is I guess what I'm saying.
May I ask, like, what some of those, like, some of the writing on the wall was for the end of Flask?
For Flash?
Yeah, Apple quit supporting it.
Yeah.
You said Flash?
Yeah.
Oh, never mind. Yeah, I totally know that. I thought you said Flask. I'm sorry.
That was a thing that, like, even the public kind of knew about when Steve Jobs said that Apple would no longer be supporting Flash. If your primary, like, revenue stream was doing Flash development, time to fucking, like, build a new skill set, right? But that Steve Jobs announcement was 2005. I was still working with Flash developers in, like, 2012. And I was like, what are you doing, guys? Aren't you going to figure something else out? And they're like, but I'm so good at this. So lots of stuff is like that.
All right, thanks.
Let's talk about runtimes. So we'll use two words here. We're going to use run dash time, just slightly different, and build time. These ideas probably aren't going to be automatically familiar to you because nothing we've done in the program requires a separate build step. But with most software, historically and, like, kind of currently, you write your code and then you compile it, and then at some point you get ones and zeros that your computer understands. So source code is for people. It gets compiled by a compiler, and then it's in something that can run. So, like, maybe a good way to think of this is the kind of code that you've been writing. Somebody wrote that stuff in, like, C# and C++ and, like, a lot of that kind of stuff, and then compiled it into .exe files for Windows and .dmg files for OS X. So that's, like, the compile step. With Ruby and JavaScript, that happens in real time, kinda. It's a little bit slightly different than that with Ruby, but your browser is compiling it as it's running it. So it's not a separate step, really. But the concept is kind of the same. This we call build time, and this we call runtime. So if you have a syntax error in your code, you're missing some parentheses, you have one too many angle brackets, something like that, that throws a build time error. While you're trying to compile it, it'll go, I'm sorry, I can't compile this. You didn't write it correctly. Build time problem. Versus something that's syntactically correct, but logically incorrect. You end up building it just fine, but when you run it, you get runtime errors. because you're either it's some action that the user is taking that causes it to break. So the errors can happen at build time, they can happen at runtime. And I mentioned that the build time part of scripting languages like JavaScript and Ruby and stuff, those happen in real time, and that's because they are running on top of a runtime. So node is a runtime. So I have this node runtime, and then I put JavaScript into it, and it compiles in real time and does whatever that code is supposed to do. No separate step, because node is a runtime. Somebody had to compile node and start running it. Once it's running, we can just dump JavaScript into it and it poops out executable code. It's like a wood chipper. Questions about that idea?
When you say it pumps out executable code, wouldn't that make it a build if the thing that it's outputting is executable code and not? Oh, when you say executable code, are you talking about the ones and zeros?
Yes.
What comes out of node? Okay,
Correct.
never mind. Sorry.
Well, like that ends up happening inside the runtime. It like is generating the ones and zeros and digesting those ones and zeros, like all inside of that box. And then the thing that it's pooping out is like whatever your program is supposed to do. It's making network requests. It's making stuff show up on the screen. It's doing whatever.
What was the difference between compile and interpret it?
So what you would say then is if it's doing this in real time, part of this is that it's interpreting this code here. Since it doesn't go through a separate build step.
Okay.
Part of it doing it in real time is that it interprets it. Now, another way to think of that is, let's say I've got some JS over here, console.log hi. Okay, so that's the code that we write in JavaScript. The code that actually does that is probably some C++ code that does something like print X or something. And then that turns into a couple of other things and then eventually turns into beeps and boops. So the reason it's called interpreted is the code that's actually like running in that runtime is this part of it, the C++, but it's interpreting the JavaScript that you wrote and it goes, oh, every time that I see console.log, that just means I write this lower level, run this lower level thing that is actually that. And I just swap out X for whatever gets passed in. It's a lot more like search and replace than it is compiling the JavaScript.
I have a question.
In Transpile?
No, transpiling is a different thing. Transpiling is this compile to. The real name for that is transpilation, but it's a different thing. The difference, by the way, is with these three steps, those are all different levels of abstraction. I have high-minded, floaty, no types JavaScript going down to memory management and whatever else, C++, which is compiles down to assembly, which compiles down to machine code, which compiles down to ones and zeros. So it's changing levels of abstraction all the way down. If I go from the same level of abstraction, like, for example, I want JavaScript, but I want to add types to it. That's not a different level of abstraction. So we don't compile that, we transpile that. So if I do something like, I don't even know what the syntax for this would be, void console log, whatever. I'm just adding features to JavaScript. Or Sass, where it's still CSS, but now I can nest stuff and I have variables and I can use functions and stuff. That's not a different level of abstraction. So I'm transpiling Sass to CSS.
You're saying interpret and compile are different fundamentally.
Correct.
I guess when you showed JavaScript going to C++, I still don't think I understand the distinction on what the difference between interpreting, why that's interpreting and not compiling.
Sure, because the console.log statement doesn't get directly turned into anything. It gets interpreted as like it's like pattern matching kind of. The C++ goes, oh, every time I see console.log, run this thing that I've already compiled. So it's not turning that into it so much as it is like recognizing what the high level abstraction is and matching it with the correct low level abstraction.
Is interpreting like less computer intensive or something?
Way more computer intensive, which is why like computer science purists don't like it, because you're just adding levels of abstraction that slow down your program. However, JavaScript is a fuckload easier to write than C++ is. So that's the upside to an interpreted language.
So if it's compiled, it actually gets changed into the language?
Exactly.
Okay.
But the reason it's able to kind of do it in real time is that it's not actually compiling it. There's some pretty, by the way, just real quick, there's some pretty heavy asterisks on all of this. Like this is master's in computer science kind of stuff, and this is an hour-long talk. So, but like that's an okay mental model for how this works. Sorry, what was the question?
I think I should just be kind of settled on that because it does get more complex and stuff like that. And we could probably sit here and ask questions all day. So
all right.
I'm going to settle with that.
All right. Let's do a couple quick hits. So, Elixir is a programming language, and it is, this is kind of like what we were just talking about. Very similar idea. So there's a thing called the Erlang Vm. And what this means is it goes, I expect to be given code that is can be formatted a particular way. I'm trying to choose my words carefully here. As long as the code that you are giving me like follows these contracts, these agreements, I can run it. I understand it. And what's cool about that is that they don't need to be the same language. They just need to kind of have the same contract. And the Erlang VM will treat them all the same. For example, Erlang, it's a programming language. As you might imagine, that runs on the Erlang VM just fine. Also, and Erlang's old. Erlang is a functional programming language. And, oops, Erlang. So this was 1988. So pretty old language. Elixir will also run on the Erlang VM, and it's way more modern. But it's able to take advantage of a lot of the optimizations that have been done for the Erlang VM over the years. And so like it kind of gets a running start right out of the gate. So this idea is also super common. Way more popular than the Erlang VM would be the JVM, the Java VM. So the idea behind the Java VM is that if you have a device that runs the JVM, it can run any Java code and anything that can be compiled to work with the JVM. So what we could do is write Java and run it on the JVM. We could also write Kotlin and run it on the JVM. We could also write F# and run it on the JVM. And any device that can run the JVM will flawlessly run a program written in any of those languages. I mean, there's tons of them, tons of JVM compatible languages. And things that can run the JVM, like web servers and stuff, also robots, also cars, also your refrigerator. All those things probably run some version of a JVM, or at least can. And so neat. You can write an F# app or a Groovy app or a Kotlin app or whatever, and it'll run on all those devices. The design goal of the JVM was write once, run anywhere. I think the web actually achieved that goal much better than Java did, but that's the idea of running something on a VM.
Can you briefly explain what a virtual machine is?
Sure, it's a fake computer. So the reason that that you can run all of that code on it is like, oh, I run on computers that kind of work like this, but the computer doesn't actually work like that. It runs a virtual machine that makes the code think it's that kind of computer, even though it's a car or a refrigerator or whatever.
I have a question. What's the line between a runtime environment versus a virtual machine? Where do you go from a runtime environment to an operating system, basically?
To channel my my best Morgan Freeman, we have no idea. I don't know. There is one, and I don't know what it is. But they end up operating very similarly.
Slightly unrelated question. I see this pop up time and time again, but closure, like the language closure and stuff like that.
Yep.
I don't know much about it, but I joined some Slack channels over here, and there's tons of people who rant and rave about this functional programming language. Oh, thanks, Mom. Appreciate that.
It is a functional dialect of the Lisp programming language on, wait for it, the Java platform. So if your target machine, whether it's a web server or a car or whatever, is running the JVM, you can switch over from Java to Clojure, and we don't need any new hardware. But Java is super duper OOP, and Clojure is super duper FP. And people love them some Lisps. Lisp is it's got a pretty idiosyncratic syntax to it. Let's see if they have any examples of it. Yeah, it's like this. It's lots of parentheses. So if you like that kind of syntax and you'd like something that is functional and runs on top of the JVM, well, that would be called Clojure.
It seems kind of with all these kind of what you're talking about. I forget what it was called, but the lingua franca. It's all these different programs where you where all these different software you can program in any language and it run on basically any machine.
Correct.
And stuff like that. And that kind of gap is closing and stuff. Is that generally true?
Yes, and it's because the computer science purists who are like, it's way slower when we have all these interpreted steps and we have to run it on top of this. I have to start up the wood chipper and then put the wood into it and then it comes out. So computers are getting fast enough that overhead that you take from interpreting it in real time, it's not that bad anymore. And so the advantage of that is we have a smaller number of like runtimes and VMs and that kind of shit that allow us to do all kinds of like wacky special purpose programming languages and still run them in all the same ways. Versus once you start getting lower and you're looking at C, C++, Rust, those kinds of things, you need to write different compilers for every different kind of CPU for it to understand that. And so we create an abstraction where like JavaScript does not give a shit what CPU you have. But its underlying code probably does. The underlying like C++ or Rust is probably very finicky about what operating or processor it's running on. But we can abstract all of that away and have this explosion of languages that still run in a ton of different places. Another way you could think of this is like the browser's runtime. We write the same code and it runs on Macs and PCs and Linuxes and all kinds of shit. If it runs a browser, it runs your code. That's the core idea here. Let's hit a couple more. So .NET. So this is the Microsoft stack. Microsoft, part of like the key value offering that Microsoft has is, I'm going to start another one of these. So one of the key advantages that Microsoft has is a whole gaggle of technologies that they guarantee will work together. So .NET, can't see my cursor, there we go. .NET consists of a couple things. .NET is, their database solution is called SQL Server. If you've ever been wondering about that, it's the proprietary name of a proprietary database technology. It sounds super generic, it is not. It is a Microsoft product. The C# programming language is part of the .NET stack. So if you are programming something in .NET, you can use C#. Let's see what else goes along with that. IIS is their server technology. So this would be, if you've ever heard the word Nginx or Apache, Microsoft's proprietary alternative to all of that is called IIS, or Internet Information Services. Let's see what else is in .NET. Visual Studio, not Visual Studio Code, but like full Visual Studio is kind of part of .NET.
Is Azure part of .NET?
Yes. Azure is Microsoft's like AWS competitor. Let's see what else is in .NET. The class library. So part of this is that if you want to build a desktop application for Windows, they go, cool, here is a whole ton of classes that let you work with the Windows operating system. You want to, I don't know, access the sound card, whatever the default sound card is for the operating system. Here's the class that lets you do that. So all of that kind of comes packaged along with it. What else?
Do you have to pay to work on these technologies if you want to do it like from home?
So like very few anymore. And some of these, like, I don't even know. I know you did for like IIS, for example. You had to pay licensing fees to use that, which is one of the reasons that 99% of servers now are Linux computers running open source server software like Apache or Nginx instead of IIS. Because, like, given enough time, they got way better than the proprietary alternatives. Did you imagine, like, an open source community has 20 years to work on something and make it better and better and better? At some point, no one company can really keep up with that anymore. And that one company with the inferior product is also trying to charge people a shit ton of money to use it. So a lot of this stuff kind of went by the wayside for that reason. And so I imagine, to the extent that these things still exist, they had to have like opened up the licensing a little bit. But I honestly don't know, because like I ran screaming from pretty much all those stacks.
I know C#'s open source. Isn't it?
Yes. There we go. Looks like they probably open sourced the entire thing.
Yeah.
Let's see. They have other parts of the stack.
Well, and this is just off the top of my head, but I'm just wondering if maybe they have like watered down versions, like how Salesforce has like, they have some sandbox you can play in.
Mm-hmm.
It's like free, but like everything else you have to pay for.
Yeah, and sometimes, like, more often than not, they'll just call those different things. So a good example of that would be MySQL. MySQL was and is an open source database platform. It was bought by Oracle. And so now MySQL is the like free feature reduced version of Oracle. But since MySQL is open source, there's some people that got really bent out of shape about Oracle owning them. So they forked it. And that's called MariaDB. And there are some people who were like, "Meh, MySQL wasn't that good to begin with. Fuck it." And so Postgres is also an open source database. And now, for the same reason that Apache and Nginx and all the free server software kind of took over, Postgres is basically everybody's default now. I heard a phrase I really liked: use Postgres until you have a reason not to.
This might be a dumb question. Does Apple kind of do some of the similar stuff that like .NET does? Because I know they have like the other one. What kind of stuff do they have?
Not as much, and that's another part of the .NET was Windows Server. They made a special version of the operating system that I imagine they still make, but God fucking knows why. That was supposed to be the operating system that all this stuff runs on. So Apple's version of this, I don't think it had like a snappy name, because Apple was never really trying to solve the same problem of like, how do we create this like wide development ecosystem and we sell all these products and services that interact with each other. Like, Apple is primarily a like consumer, high-end, sell the experience kind of company, which Microsoft has never been. Microsoft is way more, we sell businesses these like interoperable tools that all work together. But Apple did have some of this kind of stuff. So they had OS X Server Edition. They actually sold physical servers for a while too. I think they stopped that like 5 years ago. Mac server. So yeah, they looked kind of like this, or this, and they ran a special version of the Mac OS operating system, and there's also some languages that kind of go along with this, like the one for a long time was Objective-C. If you write code in Objective-C, you can use that same code base for your iOS app or your macOS desktop app, like etc. They had a framework around that called Cocoa. All that got updated a few years ago, so now it's all Swift. Now Swift is supposed to be the language that does the same thing. Write a Mac desktop app or an iOS app or whatever. But like that didn't have to run. It wasn't even intended to really run on OS X server. I think this got discontinued kind of recently. And so the whole interoperability thing was never really a big selling point for Apple. They just kind of have a different market.
I'd ask a question in the chat about
Oh, yeah.
basically how you what?
Sorry, I haven't been watching the chat.
Oh, it's all good. I could just ask it. But it was basically like all the base level computer knowledge stuff that you have where you're like really talking about how code is compiling and stuff.
Mhm.
I'm just curious, like clearly that's an accumulated knowledge over years, but when you went to learn that stuff, what was your best resource? Like, was it something that you were learning from like things that you had to do, or was it something that you were learning by like independently, maybe reading a book or something? Or
Sure. A lot of this stuff is independent. Like I have a degree in information systems, which is essentially none of this. Information systems is this first place in database design and applications. It's like schemas and ERDs and like a lot of that kind of stuff. Like there's very little like actual how computers work or any of that shit. Some of that stuff comes from like I tinkered around with computers a lot when I was little, but I wasn't really a programmer or anything like that. And then when I got into the industry, I had this odd fear of programmers because I'm not smart enough to be a programmer. And then like I worked with some programmers and I was like, oh, well, I'm smart enough to do that. These people aren't so tough. And so I picked up a lot of these things by being talked down to by neckbeards for like a decade. And like they know some stuff. And boy, do they want you to know that they know some stuff. And then you go home and research. And some of that stuff comes from books. For example, this one. A lot of computer science stuff I know came from this book. I got it at Goodwill for $2. Some of it you do actually have like practical issues. You're like, holy shit, how do I, if this thing is true and this thing is true, but they can't both be true at the same time, how do I get this thing done? And a lot of times people will, it's like, that's why we have this idea in computing for solving that. And it's a recognized pattern and that kind of stuff. But a lot of it was really just trying to keep up with the Joneses and like not have people talk down to me anymore.
So you're saying it's impossible to become as smart as you without $2 and the ability to go thrift.
Yeah. What else?
So speaking of patterns, what do they mean? Like I hear the term like design patterns thrown around a lot.
Oh, good gravy. That is an
What is that?
overrated ass concept. Well, not really. Like the way that people use it, I don't super like. So a design pattern, 9 times out of 10 when somebody says that, elements of reusable, they are talking about this book. This book is well known enough that it has a nickname. This is referred to as the Gang of Four book because of these 4 authors. And it was like probably one of the more influential texts of the 90s. Might have been written in the late 80s, but might have been written in the early 90s. Very 90s kind of book, though. And there's a whole lot of great ideas in here, most of which are kind of irrelevant in 2020. But if we look at the design patterns list, where's the one I'm looking for? This one. So these are the design patterns. And actually, this isn't all of them. There's 22 of them, I think. Where's the... Nope, that's not it either. This one. There's the actual one. Dude. Give me the full-size one. Come on, man. Why do you make me look dumb in front of my friends? All right, there we go. So these are the design patterns from the Gang of Four book. Most of these are supplied by your language or framework. Holy shit, my kids. Guys, boys. All right. So a lot of these are just supplied by your language or your framework or something now, but there are a couple of these that you can get a ton of mileage out of. For example, adapter. Love the adapter pattern. The idea of an adapter is if you have two things that need to talk to each other, but this thing outputs this thing, and this thing needs the input to be something slightly different. You put an adapter in between them, and so you adapt the interfaces of two different things.
Is that almost like a serializer?
Serialization, it might actually be one of the patterns. No, a serializer probably wouldn't be a good example of that. I'm thinking more like if you request something from an API, but the API is supplying the data back to you differently than you need to use it in your application, you can put an adapter to, like a closer thing would be maybe be deserializing something into whatever your app needs it to be. So that might be removing properties, turning underscores into camel cases, that kind of thing. So the adapter is a way of handling that. Another one that's kind of common, factories. So a factory is a something that generates configurable objects. So a common example of a factory would be this thing will give you a database connection if you ask for it, but you have to pass in a configuration object, and it'll take that configuration object and give you a database connection. That's called a factory. So from the book, a design pattern is something that is like a recognized common problem that has a named best practices solution for it. And these are the classics. I would actually not recommend reading the design patterns book. It's very dense and not super useful. And I kind of eye roll when I hear people talk about design patterns. Because the people who lose their mind over design patterns are usually trying to apply too many of them at the same time. There's this famous repo called Fizzbuzz Enterprise Edition. So what's Fizzbuzz? Who can tell me?
Isn't it like a common or used to be a common whiteboard problem where you have to generate words or replace words with fizz or buzz or something like that?
That's exactly it. So you go, all right, I'm going to give you numbers 1 through 20 and pass them into this function. If the number is divisible by 3, instead of saying the number, it should print fizz. If it's divisible by 5, it should print buzz. If it's divisible by 3 and 5, it should print Fizzbuzz. Otherwise, it should print the number. So that problem is called Fizzbuzz. You can solve it in 4 or 5 lines of code. It's just if statements and shit, right? It is still every once in a while used as a dummy test in interviewing. Because you'll get people that talk a real mean fucking game about what great programmers they are and then fall flat on their faces when you Fizzbuzz them. So anyway, Fizzbuzz Enterprise Edition was an attempt to apply every single design pattern to the Fizzbuzz problem. And, oops, those are the tests. I love this. Source main Java com serious company business Java Fizzbuzz programming naming package naming program. So it has all these different interfaces for all of the different. So these are all the factories. It's got the strategy pattern. It's got the visitor pattern. It's got a printer factory for the implementation. It's intentionally supposed to be a comically large, complicated solution to this problem. And a lot of times when I hear people quacking about design patterns, they're like trying to write something like this. It's my editorial on it. So next on the list, I'll do a couple more quick hits. So Babel. Babel is a transpilation tool. What it does is, you may not have like fully appreciated that these different browsers by different browser vendors, like you write JavaScript code, it works on all of them. Like that's a minor miracle. So it happens because so we have the W3C, that's the web government, and W3C has like various different parts of it. One of them is the what WG. The what WG is responsible for the HTML spec. It's like, what is HTML? Well, that committee gets to decide. They also are responsible for CSS. CSS is further split into like 5 or 6 different committees. So they have like a colors committee and a layout committee and a units committee and like that kind of stuff. So they're determining what HTML and CSS are. Separately, I've never been quite clear on whether or not this particular committee is part of ECMA or part of W3C. I kind of think it's part of W3C. Is TC39. TC39 is the JavaScript government. They're the people who say what JavaScript is. And so they publish, they're also split into all kinds of committees and shit. But they go, okay, something is JavaScript if it like does this and this, and we want to add this new feature, and they have a whole like process for how something like destructuring or promises or whatever gets added into the language. And once they do that, they go, cool, that's what JavaScript is. All right, browser vendors, go. And so then Microsoft and Mozilla and Apple and all of these companies need to implement that spec. And so that the JavaScript that you give them will run the same in Safari and Firefox and Edge and whatever else. So sometimes the browser vendors disagree. They go, nope, not doing that. They're like, but it's the spec, and you agreed you'd implement the spec. And then Apple goes, well, sorry, Service Worker fucks with our business model, so no. But you, the developer, like, you don't care about any of that. You just want to write your code, right? Also, older versions of browsers. You go, oh, not everything's an evergreen browser. Internet Explorer and Safari still do Big Bang releases. And so I got 20% of my user base on old Safari. So even though Apple did implement Service Worker, like, I have some users that don't have it. What do I do? So what Babel does is you write your JavaScript however the fuck you want to write it. Bleeding edge, hyper modern, whatever. And then you say, I would like to target the following browsers. I want last 2 versions of Firefox, last 2 versions of Chrome, last 2 versions of Edge, most recent Safari, and I really have to support IE12, so throw that one in there also. And what Babel does is it says, okay, cool. I'm going to take the code that you wrote and turn it into something that every one of those browsers can actually use. Because things like destructuring, that syntax is just a shorthand. Like you can do that longhand also. Babel turns it into the longhand if it needs to, if you're targeting a browser that just can't do it on its own. That's Babel. So you'll notice that like basically all modern JavaScript at some point gets babbled. Because why would you not? Sort of standardizes the developer experience. All right, so let's talk about Babel. We've talked about .NET. Let's talk about client side, server side, and then we'll break. So everybody's favorite diagram. So this is the client server HTTP diagram. So I got a client, I got a server. I send them an HTTP request, they give me an HTTP response, and that's how we talk to each other. So when we talk about client-side code, we are talking about code that runs here. The files that it's running, those were probably also stored on a server. So if this is like our API, probably also have a server over here that has our app.js file and our CSS files and our HTML files and our image files and our movies and like all that kind of shit. So I ask for those with HTTP. I get them back with HTTP. And then once they get to the client, it tries to run it. So your client, by the way, this pattern applies to way more than just web stuff. This is any two computers talking to each other. A client is somebody who asks for something. A server is something who is a computer that provides something. But it doesn't have to just be web stuff. I ask for this file, it gives me the file. I try to run this file. That file tells me to ask for something from the API. I take the thing I get back from the API and I work with it. So client-side development in the web is code name for browser programming. Now what's kind of interesting about this is once upon a time, client-side programming used to be weak shit because client computers were slow. Like JavaScript was not very mature, so there wasn't all that much you could do with it to begin with. I mean, it was hard to do shit like make network requests. So doing client-side programming was like adding scroll effects and like that kind of shit. And then all the real programming was done server-side. This changed radically in the last 5 years. So the big shift was we got the front-end frameworks. We got Ember and Angular and Meteor and React and Vue and all these things. And JavaScript got a lot more mature. So we could do way more, way cooler shit with it. And then it made a lot of sense to take all this complexity that used to only be on the server and push it over to the client, because that's what makes it feel fast. That's what makes it feel like an app. The slowest part of every app is that network request. Click, wait, get your response. When you click it and it happens instantly, that feels like an app. That feels like magic. That's because it's running all on the client. It's just getting data from the back end. It's not requesting that it generate new pages or like anything like that. That's all the mod 2 old Flatiron shit that I cut out. So by doing it this way, we got that fast, snappy app experience. And now all this complexity lives over here. The architecture for your app lives client side. Your models and your routes and all that kind of stuff. There's a lot more of that happening client side really than there is server side. So one of the things that went along with that was, where is it? GraphQL. So like, wait a minute, if all the back end is doing anymore is it's just some dumb front for our database, well, do we really need the whole programming language thing? Do we need routes? Do we need all of that extra weight that are really just kind of remnants from when the server did all of the work? And so I go, you know what? Not really. What if instead of writing these Rails routes and controllers and models and all this kind of shit, what if we have our database and we access it by kind of like writing a SQL query, sorta, on the client, and then just sending that directly to the server. So you go, hey, server, instead of REST, instead of saying, I would like the user's resource, I would like the resource at ID 1, and I would like you to filter it by is active, or whatever. So that's how we'd write that with REST. In GraphQL, you'd write it something like select all from user where ID equals 1. So you write that on the client, you send it over to your server, and your server goes, oh, cool, you want user ID 1. Here you go. And that radically simplifies your server-side code. You don't need something like Rails to do that. You just run GraphQL over there, and it'll kind of pass your query along. All right, hit me with some questions.
What did you call that technology? GraphQL?
GraphQL.
So then REST is going the way of the dinosaur, is what you're saying?
It's definitely in that phase, like the Flash thing, where it's not going away tomorrow, but it's certainly losing right now. And it's something that, like, looking into something like GraphQL, probably about time to start doing that. And I know that's been a talk in the code school space for like a year or two. Is like, is GraphQL like sticking around? Is this a thing that maybe we should be teaching instead of REST? Because what we don't want to do is be like colleges. I have a former instructor who did something that at least some of you will probably have at some point. We'll call it like computer science envy, where you graduate the program, you get a job, you've been having a good career, and it starts getting in your head like, I feel like I'm career limited because I never actually got like the computer science stuff. And if I could just go back to school and get that, then I'd be unstoppable. So they end up doing things like going back to college to get masters and CS degrees, like that kind of stuff. So I had a former instructor who did that at DU, and like in her first class, they were talking about SOAP. SOAP is the predecessor to REST, and she's a senior engineer at Guild, and she was like, wow, holy shit, why are we talking about SOAP? This is like a little old-timey. And the professor was like, oh yes, modern architecture patterns such as REST may come to supplant SOAP someday, but for the time being, SOAP is how business is done, which is not true. Like, REST has like pervaded the industry for a decade now, and it's like kind of on its way out. Like, not quickly, but it's definitely headed that way. And so in the code school business, like, we don't want to be that, but I'm not convinced that GraphQL is like what we're going to settle on. And REST still like is a very useful mental model for right now. And like the shit that I write is still 99% REST. So, but
So
yeah, that's kind of
sorry.
where we're at with that.
Okay.
So GraphQL is the language.
Correct.
But you're saying that like the whole concept of the language is that you're communicating directly with a database. So in other words, are you saying that you would replace a backend with literally just a SQL table?
No, so it's you're not communicating directly with the database. You're still talking to a server. You're just not using the REST metaphor for it. You're writing a very SQL-like thing, but you still need to do security, and you still don't want like any jackass to be able to run any random query on your database. So like GraphQL lets you set up tiers of permissions and access and throttling and all that kind of stuff. But we're getting away from MVC on the back end if all you're doing is just supplying some data.
So what would be the alternative to something like Rails as an analog for being able to manipulate GraphQL? Like, in other words, what would be the technology change other than just the way that the URL changes that we're sending to the backend?
So like you could combine this with Rails, or you could also just run GraphQL on a server. And when your server gets the HTTP request, it goes, cool, I'm going to send this over to GraphQL. GraphQL, take it away. And then GraphQL figures out if they're allowed to make that request and figures out what the actual SQL query for it should be. Because it's not actually identical to SQL syntax. It's close. And then it makes the thing and it gets the data out and it goes, hey, server, whoever was asking for this, here's the data, and sends it back.
So I was looking into Node this morning, and the guy in the video I was watching was saying that like it doesn't stress convention like Rails does.
Correct.
But are there any kind of like scaffolding tools that you can still use for Node so you don't have to write all that yourself?
Correct. So Express is, oops, not that. Express.js it's not the only Node web framework, but boy howdy is it the most popular one. But yeah, like you read, it is highly unopinionated. So Rails, your controllers go in this folder and they are structured this way and they communicate with models like so, and the migrations go here and the command to generate a migration is like this. None of that shit like exists in Express. But to your point, Express does have a generator that you can install that will scaffold out an app for you. So if you want like a good starting place for an Express app, like I used the Express generator for years. It's a pretty good starting place.
Okay, cool.
But to follow up on, oh shit, sorry, Kyle.
I was just gonna say that you can also just open up a file and start typing some shit and make an Express app. Here, watch this. If I go some Express app, and I make a new Express app, and I install Express, and I make an index.js file, and I pull in Express, and I make an app with it, and I tell that app to listen to port 9000, and anytime you get a GET request to the root, then you should respond with a message that says hi. Cool. That's an Express app. If I run this, node index.js, and I go to Port 9000. Cool. It's that lightweight. And as you might imagine, there's a whole bunch of different ways I could have done that. That's an unopinionated framework versus, say, Rails.
Okay.
That's really cool, Kyle, but can it run Minesweeper at 60 FPS? I'm just kidding.
Fuck you, Brad.
I actually saw a job posting. This is just to kind of tag along with that. I actually saw a job posting using Koa, which was kind of odd. I was like, that's unexpected, for it was like, we're looking for like Node backend people, but we also use Koa. And I was like,
so that's really,
5 other people, I think.
to Node developers, that's really attractive. Because Node got really popular very quickly, and it became a default. So a lot of default companies started making it their default runtime for all their backend shit, which attracted a lot of default developers who did default jobs at their default code. So it's like not exactly like robust and inspiring projects to work on. So Koa was an alternative to Express, is an alternative to Express. And there's a lot of value in, or a lot of signal, I guess, in somebody who likes Node and went with the second choice framework, because it shows that they intentionally picked a runtime and then intentionally didn't use the default. That alone communicates a level of thoughtfulness that a lot of companies don't have. And Koa is delightful. Like it came out after Express and was like designed to overcome a lot of the gripes that people had with Express. That's also super unopinionated, but yeah, if I see that in a job posting, I go, interesting, good choice. Whereas if I see, we use Node backends, that could mean a lot of things, and not all of them are good.
Thanks for the project idea.
Banging. All right, I think Ahmed wanted to chat with you guys a little bit. Any last questions before we wrap? All right, was this cool? It's the first time we've ever done something like this. I thought it was fun.
Yeah, I thought it was very helpful.
Fun doesn't always mean educational, so. All right, cool. Well, let me know in the survey comments at the end of the day. Elsewise, have a good one, gang.
Yeah.
Thanks, Kyle.
Yep.